So I have done 5 of these: power 2, power 3, power 4, power 5, right? The first observation that you do note is if your power is 2, the number of terms that you are getting is 1 more than that power. है ना? यहाँ पे number of terms हो गया 3, correct? Similarly, if you look at the power 3, then the number of terms that you have is 4. Again, it is 3 plus 1. So the number of terms is 4. So that is one observation that you can keep in head. That कोई भी power हो, अगर a plus b to the power of let's say 96 है, and if I ask you how many terms will that expansion have? That expansion will have 97 terms. Okay, one more than the power. So that's your first observation. Okay, number of terms will be 1 plus the power. Correct? क्लियर है ये? सेकेंड ऑब्जर्वेशन क्या है अगर तुम चेक करो कि जो भी टर्म्स है ना मेरा, उसका जो टोटल पावर है वो ये पावर के इक्वल है. जैसे इफ यू लुक एट दिस ए हैज अ पावर ऑफ 2 विच इज इक्वल टू द एक्सपेंशन का पावर दैट दे आस्क्ड अस टू एक्सपैंड. ए बी अगेन 1 plus 1 is again a 2 which is again the same, again here also 2. So each of those terms has the powers of each of those terms के coefficient, the power should be 2, the sum total should be 2. Similarly यहाँ पे देखो 3 है, a का पावर 2 है, b का पावर 1 है, sum total is 3. Again here also 3, here also 3. Go to any random term. Let's say come to this term. The power is 5. So if you see 4 plus 1 is 5. Okay. So this is a very interesting observation here. And why is it important? Because there are certain questions where you will get as to find the coefficient of x to the power of 5 in the expansion of a plus b to the power of 9. Something like this. Okay. Now you will not sit and write this entire expansion, but you will figure out that, okay, if it is x to the power of, okay, there is no x here. Let me write down an x here. Suppose it is x plus y to the power of 9. Okay. So when you expand this, you know that I need this as a power of 5. So if this has a power of 5, this y, very good. Bang on. Correct. सही है. तो ये चीज इसीलिए जानना जरूरी है कि the sum total of the powers of every term in that expanded form has to be equal to the power. Okay, this power. Clear? Is that clear? Yeah. Now we've sorted the number of terms that each expansion will have. We've also discussed of the pattern, I mean the total powers. Now let's look at how the the first term's power and the second term's power is increasing or decreasing. Now if you look at a plus b whole cubed, now see the first term, which is a, has the power as 3. It means it starts with the highest power and it keeps dropping down, okay, by 1. So as a keeps dropping down, the second term will start increasing. That's how the pattern is. You can check. So when a was power 3, you could have considered a b as a power of 0. Similarly, the power of a got reduced by 1 here and the b's power got increased by 1. In this third term, the a's power got reduced further by 1 and the b's power got increased by 1 again, giving you a 2. And in the last term, you can see the a's power has now reduced to a 0 and b's power has become a b cube. So if you look at the extreme ends of any expansion, you will always see this a4, b4, which is the highest power again. So if it's a power of 7, you will definitely have a a7 and b7 on the extreme ends. If it's a 100, you will have a100 and b to the power of 100 again on the